Hi, everybody. I hope everyone had a good weekend. I've decided to post the answers for homework 10 so that you can check and then ask me questions to save time. Okay, so you do not have this in your packet, but you are going to need your classwork packet. You are going to open up to SLT 11. Okay, so I thought we'd do a little review. This would have been the warm up or something similar from last year and parabolas. Last year in a parabola, we had questions like x minus 1 squared plus 2, where we learned this was our h and this was our k, and our hk was our vertex. So our vertex was what at 1, 2? AOS. It was really the same thing as the line of symmetry. And that would be at x equals 1. It was always the x number going across. If I looked at the second example, I'd have it as this is my HK, 2, 5, just reminding you from earlier this year and last year, we always do opposite of the parentheses. And then I know my line of symmetry or axis of symmetry was x equals 2. I know I'm going to have answers on both sides of the line of symmetry. Reviewing from last year, how did I graph those? So when I graph them, you can go make an XY table and put in all of these numbers. Usually I started with the vertex, which would have been 1, 2, and then I could have plugged in 2 and then 3 and then found the answers and then gone. So for example, 2 minus 1 is 1 squared, which is 1, plus 2 is 3. And I know that would also be a 3. I find it easier just to do the parent function, which is y equals x squared. So I know 0 is 0, 1 is 1, and 2 is 4. I know if this is my vertex, I can use this to help me. From the vertex, I'm going to go over 1 up 1 and a match, over 2 up 4 and a match. And look, see if we were doing it the regular way by plugging in. Do you see how I have an answer at 1, 2 up 3 and an answer at 0, 3? So I tend to like the parent function, but you are more than welcome to do it the old-fashioned way, as they say, where you put the vertex in the middle. Same thing here. Look, if this is my xy, my vertex is at 2, 5, I need an answer at 3 and an answer at 1. So if I plug in 3, I get 3 minus 2 is 1, 1 squared is 1, times 2 is 2, plus 3 is 7, which means 1 has to have an answer at 7. To avoid doing all that multiplication, what I do is, again, I do the parent function. So I go to my vertex. Normally, I should go over 1 up 1, but because there's a 2 here, I'm going to double it, go over 1 up 2. And notice you get the same answers. So that's a little bit of review from last year. This year is a little bit different. One of the things that might be different is how it relates to all the rest of the conic sections we've done. Remember when we did the conics, we always put the y with the y and the x with the x? And so, yes, I could bring this over minus 2, and then I could that would be the same thing. And there's my parenthesis. This and this are the same. And same thing here. So sometimes you'll see it like this, and sometimes you see it like this. I happen to like this because it's similar to what you already know with your HK that you learned last year. If you like it like this, great. Okay, so how does it relate to all the other conics we've done? Do you remember all the other conics we've done, hyperbolas and ellipses, we use our exploragons, and we had a focus. Each of the other times we had 2 focus, we called them foci. Now we're going to have 1, but we're going to have something called a directrix. Similar, what does a locus, remember that meant series of points equidistant from the fixed point, focus, but this time now we're going to have a fixed line look like. So instead of 2 points, we're going to have a line and a focus. Okay, so just like before, this time they're equidistant. So I picked 2 that are the exact same. So you can see I took 2 purple, I put 1 on the focus, 1 on the directrix. Notice it has to be perpendicular. So if this is in your packet, if you could find your packet and find the page that has this picture on it. Okay. And you can just draw a sample as we go. If we were at school, we'd be using the Explorer guns. I would be using the aqua. Here is 2 aqua, equidistant. 1, 2. And what we get is that ends up being our vertex. We have a green and a green. We have a yellow and a blue and a blue. Notice this is my focus. This is my vertex. This is my directrix. So last year we talked about everything that related to the vertex. This year we have a focus and a directrix. We're going to learn a new letter. It's P, and the P just stands for the difference, how far from the vertex to the focus. It's the vertex to focus. You'll see as we get to the equation. Okay, we are on page 44. So again, the shape we made is a parabola. And again, this new distance right here is going to be called the p-value. And again, it's the focus, it's the distance, if you're taking notes, from the vertex to the focus. Okay, so how does it compare from last year? Last year, we only had things that opened up and down. So you don't have this in your page, so just in your packet, so just watch. When it opened up, it had a positive A. When it opened down, it had a negative A. This year, we're going to have left and right. So if we think of this equation, it looked like this last year. But now, if I want to make it go negative, just like last year, I made the A value negative. If I want to open up left and right, similar to a directrix, similar to a hyperbola, up and down, y came first. Left and right, x comes first. So if I want to open up right, that's going to be positive 3. But notice I switched my x and y. X now goes with y squared. If I want to open up left or negative, I'm going to have a negative. And notice x comes first. We flip-flopped our x squareds and our y squareds. Okay, now we're on page 47. Okay, so I'm going to write the formula for each one, and then we're going to talk about where I got this. Label the focus and the directrix. Here's my focus. Here's my vertex. Here's my directrix. Okay, notice it's opening up left. That tells me I'm going to have an x first. And I know it's going to be equal to a y squared. This one opens up down. So I know that's going to be a y equals an x squared. It's opening up back, so I know it's going to be negative. Opening up down, I know negative. Now, this is equal to, notice, this p-value is worth 1. And this p-value is worth actually -1 both times. So, this is going to be 1/4 and 1/4. Where did I get that? Okay, because technically what we learned last year, the A is really the same thing as 1/4p. 1/4p. Last year you learned it as, okay, I'm going to go from the first one and I'll go over to number 1 and I'll see how far down I went. I went down 1/4. That's where we got 1/4. It's a little bit easier because you don't have to figure out that first slope. Now we can just simply know that it's going to be 1/4p, and this is our p distance. Okay, so just reviewing from a little bit of last year. Last year you had it like this, and I don't care. I'm going to keep it like this year, but sometimes you might see it written like this. Again, bringing the k over. But now, don't forget, we're not going to just have a y equals. We might have an x equals. The a stays the same, but remember the k is to go with the y, and then the h goes on the outside. And remember what I said, the a was equal to 1/4p. Okay. So, why do we care about this? Well, in some ways, when you know the directrix and the focus, it's actually a little bit easier to figure out that A value. last year we called it A, and we never said, hey, by the way, the A is equal to 1 over 4P. Well, that's what it is. And the P I said to you was how far from the vertex to the focus or the directrix, either one. Okay, because they're the same. So let's try a couple. I personally write it like this. Some people write it like this. I'm going to write it, if it opens up and down, I'm going to write it as y equals 1/4 p x minus h squared plus k. And then the same thing here. X equals 1/4 p y minus k squared plus h. So things we have to look for. The h and k is the vertex, easy enough. And now we have to look at the p value, and that's that distance. Okay, we're on page 49. What would the symbol of representation look like? Meaning, what's the equation? Okay, if it opens down, we know down is a y equals. So I'm writing it as y equals 1/4 p x minus h squared plus k. If you want to say the minus k on that side, please do it. Okay, it opens up right. That's not going to be a y equal, but an x equal. Everything will be the same. 1/4 p. This time it's going to be y minus k squared plus h. And again, you can bring the minus h over here if you want. Opening up left, same thing. X equals 1/4 p, except these to me are both going to be negatives. I forgot. Y minus k squared plus h. And again, these are all for parabolas. Okay. So the last two for today. I want to write this in standard form. So we call this standard form. Our parabolas in standard form. Okay. So I personally am going to get y to stand alone. Right now, my job is to get y to stand alone. So the first thing I have to do is make this into a perfect square. So just like we did before, x squared minus 4x plus I don't know equals negative 12y minus 16. I'm getting my perfect square first. I know this is going to be x minus 2 squared plus 4 plus 4. So here is what I have so far. What's my next step? I got my square. Got my square. Now I'm going to get y to stand alone. I'm going to get rid of this 12. X minus 2 squared plus 12 equals negative 12y. My last step, get rid of that negative 12. Divide this by negative 12, this by negative 12, and this by negative 12. X minus 2 squared over negative 12 plus 1, or minus 1, sorry, minus 1 equals y. So my vertex is my HK. My vertex is going to be at 2, negative 1. Okay, same thing again. I'm going to, I notice here I've got a y, but an x squared. So this is similar. X squared plus 2x plus I don't know equals this. I'm going to bring both of them over. 16y minus 33. Now I'm going to finish. X plus 1 squared, making it a perfect square first, just like we did in the last units. And add 1 to both sides equals 16y minus 32. Now, get y to stand alone. Get rid of that 32. X plus 1 squared plus 32 equals 16y. divide by 16, divide by 16, divide by 16. X plus 1 squared over 16 plus 32 divided by 16 is 2 equals y. I can write it like this, or I can write it like that. Doesn't matter. And therefore my vertex is at -1, +2. And we are done. Sorry, I didn't realize it went off the page for today.